In coordinate geometry, one of the most fundamental operations is finding the distance between 2 points on a plane. This concept builds directly on the Pythagorean theorem we've likely seen in basic geometry. Let's consider two specific points on our coordinate plane. We'll denote our first point as x sub 1, y sub 1, shown in blue, and our second point as x sub 2, y sub 2, shown in green. Our goal is to find the straight line distance between these 2 points. This distance represents the shortest possible path from one point to the other. While it may not be immediately obvious how to calculate this distance directly, we can use the Pythagorean theorem by forming a right triangle with our points. The distance formula isn't just some arbitrary equation to memorize, it's actually a direct application of the Pythagorean theorem in a coordinate system. In the next part, we'll see how to construct a right triangle using these points and derive the distance formula by applying the Pythagorean theorem. This will give us a general formula that works for any 2 points in the coordinate plane. To find the distance between 2 points in coordinate geometry, we need a method that works for any 2 points. Here, we have point P1 at coordinates x1, y1, and point P2 at coordinates x2, y2 plotted on our coordinate plane. Let's create a third point P3 with coordinates x2, y1. This point has the same x-coordinate as P2 and the same y-coordinate as P1, creating a right angle in our construction. Let's draw a horizontal line from P1 to P3. Notice that along this line, the y-coordinate stays constant at y1, while the x-coordinate changes from x1 to x2. This horizontal distance represents the change in x-coordinates between our 2 original points. Now let's draw a vertical line from P3 to P2. Along this line, the x-coordinate remains fixed at x2, while the y-coordinate changes from y1 to y2. This vertical distance represents the change in y-coordinates between our points. By connecting these 3 points, we've formed a right triangle. The right angle is at P3, while P1 and P2 are at the other 2 vertices. This geometric approach gives us a way to calculate the direct distance using the Pythagorean theorem. The length of this horizontal leg can be calculated by finding the difference in x-coordinates. That's x2 minus x1. In our case, that's 3 minus -2, which equals 5 units. This horizontal distance is crucial because it tells us exactly how far we need to move horizontally to get from one point to the other. We can think of this as the run in the rise over run concept from slope calculations.